Hello and welcome. Today we're going to be doing something that's a little bit unusual, I think. We're going to do something effectively creative coding-ish. I have this image for my wallpaper on my desktop. and I've got a different image that I use for my like lock screen, but they both kind of have the same idea, which is that it's like some sort of image with this like geometric overlay, like filter, I guess, applied to it. And I want to implement something like that. That just seems like an interesting thing to implement. I'm not even certain that it's going to be good or like useful in any way. I'm sure it already exists, but I want to try doing that myself. So the way that we're going to do this is I want to first do it using a Voronoi diagram, which doesn't get the same kind of like triangle geometric shape, but I think it'll be interesting. And then if we have time, I want to try doing this Bowyer-Watson algorithm, which is used for triangulation. So we basically take some points and we draw triangles between them, which is effectively what we need to do in order to get this kind of thing. But we're gonna do that after we've done the Voronoi diagram, because I think that'll be a little bit easier to do that. I don't think that they're particularly related. I think that they're like sort of tangentially related. Like I think in the Delaunay triangulation thing that I pulled up, it has a similar like there's a whole section here detailing the relationship. I don't really care about that. I just kind of want to try it on the Voronoi diagram. And then yeah, we'll see how that goes. I do have this image. I have it saved locally so we can open this. It's just this that I found on what is this site? Unsplash. That we're gonna try it on this. I think this will be a good candidate potentially. We'll see for doing this, but yeah. So let's see about that. One thing to note, I have, and as you might have seen from the I don't really want to call it a pre-stream, but like the little title card before I start the stream, I have made some changes. So I redid my OBS setup because I replaced my system, or like reinstalled my system. So now I'm running like, Sway with Wayland. And this is the first stream happening on this, so there might be things that are broken. We'll see. Hopefully nothing's too bad. I've been using this for about a week now, or a few days, 4 or 5 days. And everything seems to be working, but there's always a chance that things are going to break. So just heads up that if that happens, I'll have to take care of that. But hopefully we're fine. Anyways, let's get started. So I have this directory here that has just this image in it. We're gonna create a main.c. We need to make this text a little bit larger. Quite a bit larger. Okay. And we'll just say printf hello world. Also, my font is currently a little bit broken, so you'll see that we don't have our little panda here anymore. My cursor is also a lot smaller, so if that's an issue, just somebody let me know. And I'll make it bigger. The world include standard io.h. Oh, and then there's also that issue that I need to figure out, but we can ignore that for now. Right, so we've got our main. Let's create a makefile. gco main.c, and make and main. Great, so we get our hello world. We are professional C developers. I'm glad that we can do hello world. Oop, we did not do this correctly. We need to exit with a non-zero, or with a 0 exit. Perfect. Great. So we're going to use raylib for this. raylib.h as always. So we need to do init window. The dimensions are going to be a little bit weird here. I think we'll scale down, just because, like, I don't know, we don't need to do any, like, we ideally we have it as like full resolution, but that makes it a little bit annoying to play with. So let's scale down, and then we'll see if we can figure out a good way to scale it back up, or however that's going to end up working. But yeah, so let's do 800 by 600, And then the title is just gonna be like Voronoi wallpaper. And then while window should not close, we're gonna begin drawing, end drawing, and then we'll close window. Close window. Typing is not going super well today. I feel like I say that every day. Okay, so we are drawing, and then inside of here, let's, for now, I guess let's do a circle, or let's clear background with gray white, and then let's do a circle, draw a circle at 400, 600, 200, or not 600, but 300, and then color here is going to be red. And if we make and run, right, we need to link with Raylib, obviously. Raylib. Bam, we've got Japan-ish. Obviously the proportions are a little bit wrong. I think we are definitely going to want to do some anti-aliasing though, so let's get that in. So what is that? That's set config flags. Flag MSAA for accent. Anything else we want? Like, we're gonna do flag floating. Actually, I don't want resizable. That's what I was thinking. I don't make it resizable. Great. So now we have anti-aliasing, so it's a little bit smoother. Also, something that I lost while switching to Wayland was my that zoom tool that I use, but I haven't quite gotten another one that works with the same level of like that works as well. This is the closest we can get, which I think should just work pretty well for you guys, although it is very much different for me because it only covers one monitor, but it is manageable. Okay. Great, so now we've got our standard little boilerplate for Raylib. Now let's figure out how to load this image in Raylib, something I have never done before. So I think there's an image, and then there's like load image. Okay, and then you just pass a file name. That's wonderful. Initially, yeah, okay, so we get image. And then how can I draw image? No, I think you need to do a texture. There's a texture. Let's go look here. Let's see what takes an image. Unload, export, image generation, image manipulation. Okay, get image stuff. This is going to be a function that we want to use quite a bit, I think, but not yet. So this is drawing into an image. Load texture from image is something that we want to do. Yeah. So texture 2D, is that what that returns? Yeah, texture 2D, texture is this guy. Nope, this guy. And in here, no, that's not a string. That's going to take the img. So now we have our texture. And then we can say draw texture, texture at, I don't know, like 50, 50. And then this is going to take white. Bam. Hey, look at that. We have an image. Great. Obviously, it's scaled really, really badly. There's a draw texture. What is it? X? No, because you position. Rec takes a source and a position. Do I really have to use like the pro? I think I have to use the pro. Oh, that's a little bit annoying, but that's fine. Okay, so pro is just, it's like the most complicated one. But we need to have a rectangle on the screen and a rectangle in the image itself in order to actually scale it. And this is the only one that does That's fine. Okay, so we have texture. Source is going to be a rectangle, which has x is 0, y is 0. Width is going to be the texture width, and height is going to be texture height. Wait, what is the phi of the rectangle? Oh, it's literally width, and height. Like that. Bam. Okay. Then what else do we have? We've got the destination, which is the like where on the canvas it goes. So here we're gonna say, sorry, let me just format this a little bit. Great. And then here we're gonna say rectangle, this guy. And this is gonna be x is, and I guess we can just say 0, 0, or 0, y is 0. Width here is gonna be, let's do define width is 800, width, let's say height is 600. Honestly, this should be, like, we should be specific and say that this is 16 by 9, times some sort of, like, scale, or like some sort of scale. And then we can define scale. And then if we'd said node dash p 800 divided by 16, what do we get? 50. So this should get us roughly the same thing that we had before. What is what, 9 by 50? 450. So this is gonna be 16 by 9. Before we didn't have that. We had what, 8 by 6, which is 4 by 3. Okay, so now width here is gonna be width, and height is gonna be height. And then what else do we need? So we needed the origin and the rotation. So the origin doesn't actually matter because we're not rotating, so it can just be vector 2, 0. Is that a thing? We have to include Ray math for that. Yeah. Okay, so vector 2, 0, which is just like the 0, 0 vector. And then we also need the rotation, which is 0f. And then we need the tint, which is this guy. So all of this is required to print, to show this texture. Great. And it is shown correctly on the background. This dimensions is not correct though. So this is width, this is height, and we can also get rid of this circle and the clear background. Ooh. Clear background should actually occur first, technically. But okay, great. So now we've got our little image here. And then we can bump up the scale, I think. It doesn't need to be that small. So we can say scale is 75. Yeah, okay, that looks decent. I am okay with that. Great, so now we've loaded the wallpaper, or the actual texture itself. I want to, hold on, I want to confirm, 2670 by 1780. Node P 2670 divided by 1780. That is not 16 by 9. That is what, 4? Is that 4 by 3? No, that's 4 by 6 over 4 is 4 over. What? 3 over 2. I'm being dumb. That's interesting. So our scale here is a little bit different. So 3 over 2, or 3 by 2, is the Oh yeah, and then obviously it's significantly smaller now. So it's let's do like 200. Wow. Let's do 400. Okay, now this is accurate. Perfect. So now that we have this, we're actually gonna kind of ignore this. We're gonna remove this drawing of the texture, which honestly I think doesn't even matter. And now we're gonna do the Voronoi. I think I'm gonna mispronounce it a bunch, but we all know what I mean. So first of all, I want to create like a dynamic array of points. Yeah. So let's grab. Where have we done dynamic array stuff before? You know what? Let's grab github.com coding knob.h. Yeah. So this is a what's the term? It's effectively a build system. But I don't actually want any of that. I just want to grab one of these macros, which is knob da append is what it's called. This guy. Not this guy. Why are you knob da append? Why is GitHub so? What? Oh, that one is on me. Okay, so it's this basically, and this is. I mean, it looks a lot more complicated than it actually is, and I like to just copy it because it's easier than actually spending the time writing this out. But effectively, this is a macro that allows you to push to any sort of structure that matches the requirements of a dynamic array. So also, you can go away, This is like C++ stuff. Realloc is just realloc. And then this is just assert. And then we need standard lib, and we need assert. And then I think that this should work. Yeah. And so basically how this works is you can define a structure, which is a points. This is not how you define this. Type f struct points. And then in here, you have a pointer. So in our case, that's going to be a vector2 pointer, which is items. And then you have a size t size and a size t capacity. And then we can create a points. So we can say points p is just 0 initialized. And then in here, we can say if is mouse button pressed. And this is going to be mouse button left. Then we're going to say p dot no, this is the wrong language. Da append. Right, it's got this non prefix, which I don't care about. Da append. It takes a dynamic array, which in our case is points. And then it takes the thing that we wish to append. So in this case, it's going to be get mouse position. No member name count. Right, it's not called size, it's called count. And then it just works. And so I think we can expand here, and you see it expands into all of this garbage. But eventually what happens is that if it's empty, then we're going to just create some capacity. Otherwise, we're going to keep trying to grow it. And then we're going to just allocate that memory. And then after we do that, we're just going to push the item. So it works just like a dynamic array or like a vector or something. But it works in C, which is super handy. And it works with any type. That's why it's not just a function. That's why it has to be a macro. So you can have any number of different dynamic arrays. This is kind of how you get around not having generics in C, is you use this little structure, or you use macros in horribly convoluted ways. But cool. So now what? Now let's loop over the points. Not int, size t, I is 0, I is less than p dot count. And then we're gonna say draw point, no, draw circle. Why can I not do that? Draw circle. Is there a vector? Yeah, v. And the center here is gonna be I, no, it's gonna be p dot items at I. And then the radius is gonna be like, I don't know, 3. And the color is gonna be, let's just do black. Actually, let's do white, and then let's clear with 19. Like that. So now we've got this, and then we should be able to click and place a point at our mouse cursor. Like that. Beautiful. I do hope that's showing up. These are kind of small, but it looks like they are. So, cool. Yeah, great. So now, based on this, I want to actually do the Voronoi diagram. So how do we go about doing that? Not this, this. So there's a bunch of math in here, but the way that I understand this, I don't remember if there, yeah. So there's a bunch of stuff here, but it is reasonable to assume the customer from the distance. They'll go to the shop located nearest to them. Right. So this kind of, so there's a bunch of math in here, but this is really what it is. For every pixel on the screen, effectively, just color it in based on the closest point. Right. So in here you've got two different examples. One is so what does the closest point mean? So on the left side, you've got the Euclidean distance, which is like the standard distance function that we're used to. That's the square root of the difference of the x's squared plus the difference of the y's squared. Basically this. I don't know how that, but basically whatever this says. And then there's the Manhattan distance, which is like the sum of the differences in the x's and y's. But yeah, so we're basically going to create this kind of coloring before we do anything with the why is my brain blanking, before we do anything with the image itself. So let's do that. I want to, okay, so within a texture, can I like draw to specific pixels in the texture? We're not going to do anything in like GPU or anything. I think technically we could, but I don't think it's worth it. We can draw into an image. But I don't think we can draw directly into a texture, which kind of makes sense because that's a GPU thing. That's fine. So let's do that then. So we're gonna first of all create a texture, or create an image. Image. Voronoi is going to be create image. What is it? Image manipulation, image generations, gen image color. Yeah, that's it. So we're going to do gen image color, which takes the width, the height, and the color. So we're going to say width, height, and color is going to be we can just do white, I think. And then we're going to load the texture. And then we're going to draw a texture. And this one we can just use the normal draw texture because we already know that the texture is the right size. So texture here we can say is V for Voronoi texture. position is going to be 0, 0, and then the tint is going to be white. And so now we should just get our white screen back. Oh, we still have, oh, interesting. Can I do this without creating new textures? I don't know if there's any harm in actually like creating new textures every frame, but I would rather not if we can avoid it. Yeah. Let's see. Can I say draw? I mean, really, like, what I want to do is just be able to draw a pixel in a texture, but I'm not sure that I can. Because there is literally just load texture from image. Texture configuration, texture drawing. No, this is for drawing to the screen. Color pixel related functions. This is for like color, like math. Interesting. Is there no way to like actually or like just update the texture? Maybe it doesn't matter. I mean, we can unload the texture too. So we can just say down here, let's unload texture, v texture, which is a little bit better, I think, because the IDs aren't incrementing anymore. But I think this will be fine for now. We can. Oh, that's why. So this needs to be Voronoi. That's why we're getting that, the mountains in the background. Okay, so that is that. That seems to be fine. Now, let's iterate over the textures, or iterate over the pixels. For size TP in, not in, size TP is 0. What am I doing? Y is 0. Y is less than the, and this needs to happen, I guess, here. So Y is less than, I guess, height plus Y. And then do the same thing on the X's. So X, width, and X. And then in here, we're gonna say Voronoi dot, or no, what is it? It's draw image draw pixel. I don't know why if I press backspace everything goes away. I need to fix that. That's actually driving me nuts. But it's fine for now. Voronoi, we have an X, then we have a Y, and then the color here is going to be dependent on what the closest point is. So what I want to do is I want to give every point a color, and we can do that by, if we go to the definition of white here, we see that there's a large amount of colors that are defined. Let's just copy this, and then we can put it here. And then let's create a static colors is this, and then we can do a little bit of Vim magic, and we'll delete space, and delete and comma, and indent. Great. So now we've got this array, which is the list of colors. Brackets are not allowed. Oh yeah, this is not Java. Those go there. So now we've got the just array of colors. It doesn't really matter what the colors are. They just need to be different. And honestly, this should probably be shuffled. Just because by default, some of like the similar colors are directly next to each other. Okay, and then we can do a define or size t colors len is no. Let's define this. This is fun. Define is size of colors divided by size of colors. Okay, and then in here we can say colors. Or so, then in here we need to find the closest point. So let's say 4p in. What the fuck am I doing? 4. This is not Rust. I'm very much writing Rust for some reason. 4 size t. I is 0. I is less than p count. So iterate over all of the points. And we'll say size t min I is 0 is -1. Size t min. This is going to be actually the minimum distance. It's going to be a float. No, I don't think it needs to be a float. This can be a size t as well. Or let's say an int. And then this is going to be, by default, since it's a minimum, we just need a big number. How do you, what is the, like, I32, int 32 max, this guy. And this is from, what, standard def? From standard int. Why do you import like you're in C? Plus. Great. So this is just going to set it to default to be like the maximum possible. And then here, we can say if min is less than, or if min is greater than, the distance here is going to be p items at I dot x minus x, so minus the current pixel, squared. Okay, let's actually just break this out a little bit. Dx is this guy. Int dy is this guy, so with y instead. And then this is going to be dx times dx plus dy times d. And then we don't actually need to square root because that wouldn't change our minimum at all, right? So like if we are, yeah, like that just really wouldn't change it. So if min is greater than distance, then we can say min equals distance, and then min I equals I. So if min I equals -1, then we just break, because we don't have anything to draw. That means that we have no points. Although no, we can actually, let's assert min I is not equal to -1. And then here, right here, let's say if p.count is greater than 0. So that we only draw this if we have points. And then if we have any points, then we know that we always have a minimum value of some kind. Okay, great. Now we need to set that pixel. So the pixel is going to be pretty simply just colors at min I mod colors. Like that. Okay, so we have an issue. VTexture is undeclared. That is true. Something was wrong with this indentation. What is going on? Yeah, like that. So VTexture is undefined or undeclared. That's fine. We can do this. I don't know if it's going to be happy with. Although I think actually as soon as we draw it, we can just unload it. So So if we just dump this there, I think we're fine. Okay, so we've got nothing, which makes sense because we have no points. And then if we place a point, the entire screen gets colored. This feels like the wrong color. Yeah, I feel like something here is wrong. It should not all be black. So let's see, maybe it's this unloading that's breaking it. Yeah, so unloading it is breaking it, otherwise it's working. That looks cool. So I think we need to unload the texture at the end, which is fine. So we can say a texture, 2D texture. And then I don't know if we can just always unload texture. What is it called? It's called V texture. I think I need to fix the name. Yep. So I don't know if we can just always unload it. Yeah, okay, so we can. That's cool. If we put a dot, the screen changes to green. Put another dot, we should get it divided. Put another dot, it should get divided again. Yep, okay. That was weird. I don't know what just happened. My entire screen just froze. I'm mildly concerned about that. Oh, the entire TMUG session just died. I feel like it has something to do with us loading and unloading these textures. That seems less than ideal. There's gotta be a better way to do this. Like, there's no way to draw an image directly as far as I'm aware in Raylive. What am I doing? Like, draw image is not a thing. Is there a way to modify the pixels within a texture? Not really. Oh, yeah, because it's just a wrap around an OpenGL texture. So let's see. Do we have anything that like accepts an image? Set window icon. Okay, clipboard image. Load image. Export image. No, that just saves the image. Generate images. Right, so we've got all these functions for actually manipulating an image and like drawing into it. Let's see if the Raylib website has any sort of examples that cover this. If I look up image, what does this give us? Image drawing. So this is just drawing into the image, and then this is loading the texture from the image, which is what we're doing. We don't unload the image, that is true. Yeah, that's the only real difference that they have in here. But the other, well, like a big thing is that they're not updating the image within like the main loop. What is this? Actually, this is a good one, I think. Except it's not. They're still not updating the image within the loop, which is what I want to do. Although in reality, like, we don't need to do it in the loop, I guess, to be fair. But before we do anything, let's unload the image after we draw the texture. Let's see if maybe that'll help some. Yeah, I think maybe that helps a little bit. I mean, doesn't seem to be crashing, and this is about like where it was crashing before. So maybe this is gonna work some. But yeah, you'll also notice that like I just placed a yellow on top of a yellow, even though those are distinct points, and that's one of the aspects of how we're just choosing color is gonna not work out super well. I hope that flickering of the output isn't gonna be bad for compression, but I guess it is unavoidable. I don't want to, actually, now that I'm thinking about it, I don't think I want to move the image to only generate once, like when we click, just because I don't think it's, what I want to do in just a minute is going to make that kind of useless. Actually, what I'm going to do right now is going to make that kind of useless. I want to add a little loop here that says p dot items at I. What is it? Vector to add. Vector. Wait, do we have a vector to mod? No, we don't. I want to just do these individually. So X is going to be P. Let's just say vector to point is P items I by reference. And then I want to say px is going to be px, or not p, but point. It's going to be the x plus, like, I don't know, 5 mod width. And then the y is going to be the same thing, but mod height. So now they're going to be moving. Maybe not that fast. Yeah, let's drop this down to like 2. That should loop, but it does not seem to be. Why is it not? Oh, this needs to be wrapped in parentheses. This needs to be, I did it again. This needs to be wrapped in parentheses. Invalid operands. Float and int. Oh, are these floats? These are floats. Like that. So now if we put a point, it's gonna wrap around. Cool. So this is not terribly interesting. Obviously, it's a little bit cool around the edges, but what I really want to do is what do I really want to do? I want to give them all a random velocity. So we're gonna just say points, and we're gonna have a this isn't vectors. Like, really. And then we're also going to have a velocities, which is going to be basically identical. In fact, it's going to have like the same length every time. And then this is going to be random. Is there like a get random or a vector to random? Really? Zero. I want to go to the definition of this. I feel like there was a way to do a random. Really? Okay. I guess not. So that's fine. We can say vector to. And this is going to be what? This is going to be get random value between 0 and 1. And then we're going to say get random value between 0 and 1. Too many arguments. Oh, right, because it's a macro, you have to write these in parentheses, because C macros are garbage. Although that didn't fix it, and it should have. Wait, what? let vector 2v is that. I don't know why it's complaining. It's not. I think Clang D just shit the bed. Okay, that is fine. Great. So now we have this velocity, but this is not a great velocity because it can be really like a very large amount of like length, like different sizes. So we want to normalize it. So vector 2 normalize, and then we want to scale it up to be whatever speed we want. So vector 2 scale, and we're going to scale to 2, which is what we have down here anyways. So now we're going to say point is this, and then velocity is this, and we're going to say vel.x and vel.y. And these are both floats, which is... Can you do... I think you can do mod on float, but I think this might need to be a float for that. So this is fine. Yeah. So one other thing is that this won't work if we have a negative velocity, or I guess a velocity that is negative x or negative y, because we're only like calculating if we go off the screen, off the right of the screen or the bottom of the screen. Is there a way, does Raylib have any utilities around that? I don't think so. There's some like weird rectangle math that is offered, but I don't know that. Like if I go here, oh, this is just within Raylib itself. Yeah, there's collisions. I mean, in fairness, like the actual implementation isn't that difficult, but if I don't have to do it, I would rather not do it. Update texture rec. Ooh, can we just draw pixels? Update texture rectangle with new data. We might be able to just draw pixels directly into the texture, actually. Sorry, tangent. Yeah, that's fine. We'll just do the tiny little bit of math here. So what we need to do is we need to say, let's even do this super manually. So point x, or I guess what is it? It's vector 2 add point and vel, and then it's going to be point x plus point x mod width. And this assumes that the x component of the velocity is less than width, but I think that's fine. Right, and then we need to say int. And then that should work. So if we do this, it's going to give him... That is a really big velocity. Why is it so large? Yeah. So this is going to be vel is percent f, percent f. Oh, and then I need to actually pixel point. So what do we get? We get 0, 2. That seems Oh, this returns an integer. Really? Okay. I thought they had like a random float. I guess not. Okay. That's fine. Let's do rand divide by rand max as a float times 1. So obviously this is a really big. Yeah, but this is 2. Why is it such a massive like movement? This is wrong. Why is this wrong? Oh, because this is not supposed to be plus that, it's supposed to be plus width. Yeah, that's better. Okay, so now this is moving in a random direction. And if we do another one, that's also moving in a random direction. We do another one that's also moving in a random direction, a random direction, a random direction. Okay, that looks pretty cool. Great. So now let's see what we can do with this. What was it called? Update texture? Yeah, it just takes the pointer to the pixels. Can I get like the pixels from a texture? Is that a thing I can do? Because I don't know what is like this, because it's a void. So what's in it? Is it colors, or is it some other data type for storing the pixels? I don't know. Let's pretend it's colors. So instead of doing this, instead of like having this image at all, let's do color pixels is this. This is gonna be width times height. And then instead of setting the pixel like this, we're gonna say pixels at y times width plus x, and this is gonna equal this color. And then we're gonna say you can go away and you can go away. Then you're gonna be this. You can go away. This is gonna be create. Is there a way to just create a texture? Load render texture. And this is gonna be width by height. Like so. This is a render texture, which we can do .texture on. And I think that's okay to do, but I don't know for a fact. So we're just gonna maybe find out. Great. And then I want to say update texture. And it takes the texture. And it takes the pixels. And it does not work. Hell yeah. Unloaded texture data from VRAM. That needs to go away. Okay, so yeah, that does work. That's great. So that means that we don't have to constantly generate new textures. This is kind of cool to watch, I think, honestly. I don't really know why. It's kind of simple, but it's fun. Okay, before we do anything, I want to create a bunch of points, and they're like vectors. So let's do that. Let's say for size t I equals I think let's do this on a let's do it on a grid. Like let's just generate a no, you know what, before we do that, let's just generate like 100 points. Like without even doing anything fancy. So let's just generate 100 points at random locations. So velocity is random. And I guess inline that too. Get mouse position isn't gonna work, so let's do this one. I think we can say vector 2. And this is gonna be get random value between 0 and width. And this one I think is fine, it's just be integers heights. Ooh, wow, that is super, super laggy. I mean, I'm not surprised. It now actually has to do a bunch of stuff. But that is kind of funny how much laggier that makes this. Yeah, that is a Voronoi diagram, I guess. I don't know if clicking is broken or if it's just being super slow, but that is fine. I don't really need to. We can remove all of this image stuff because we don't actually need it anymore. Very nice. And then I think also we could just remove this like randomization. Or not randomization, but the actual velocity I think is not super necessary. It was just kind of a cool idea to play with, I guess. I do want to add like a randomize is key pressed, key R. And then this is just going to be a void randomize. Takes the points. And then maybe the number of points. And then we'll basically just do this. And we're going to say points dot count 0 to just make sure that's empty. We don't care about the velocity anymore. And then we're going to say randomize points, and we'll do 100. And it's not points, it's called P. And this is count. Great, so now we've got a function here that will randomize, and then in here we can also just call this randomize. It takes the points and it takes the count. And now let's actually remove all of this velocity code. Great, so now we're there and we can just press R and it'll actually redraw them. Because this takes a long time, let's actually just move this to happen before. It doesn't really matter when it happens. Although we do need to... We need to call this multiple times, right? Because we need to call it at the beginning, and then we need to call it every time we randomize the point. So this is going to be what, like... I don't know, let's just call it Voronoi. And this is going to take the texture. And... the points. And I think that's it. this guy. Yoink. Paste that. So P here is for points. Points. This is points. This is points. This V texture here is going to be texture. This draw text. Wait. Oh, that just takes it by value, not by pointer. Interesting. And then we can't draw the texture here. We're going to have to do that separately. But I think this is fine. And then down here, we're going to create. We're going to draw the texture. And then in here, here we're going to say if points length or count is 0, then we're going to just return. We don't need to do anything. Although arguably we do that. Instead we do that here. And if there are no points, then we're going to just update texture to be all black. Right? And then now we can say drop texture. This, and we can say Voronoi takes the V texture, takes the points, and then same thing here for this randomize. There we go. Now, something is wrong here. What is wrong? Oh, we're drawing texture, not V texture. Bam. So now we do that, and we can just reload as frequently as we really want to. Okay. Beautiful. So now that we've got that, let's take like a 5-minute break, and then we'll do the actual wallpaper and see how we can get the colors to work for that. So let's take a quick break, and we will be right back. And we're back. Okay, so, oh, do we still have the point happening when you press it? That's fine. Actually, you know what? If we still have that, we might as well do that, and we can get rid of the velocities. Now we're regenerating when you press when you click. Very, very nice. Great. So, what I want to do now is for every point, I want to have a corresponding, like, sum structure. So, type def. Right, yeah, I think that should work. So, we have this sum, which has, I guess let's do color mixing in HSL. I think that'll be a little bit better than doing RGB, because in RGB it'll all turn to like brown. I think HSL should do a little bit better, and I think Raylib has support for HSL, or maybe HSV. Yeah, it's got support for HSV, so I would rather do that. Obviously, something like OKLab or any of the other like color spaces would be better, but I don't want to implement those algorithms yet. So I'm gonna just do this. So we've got hue, saturation, and value. And then we're going to have a size t count. And then we're going to create a dynamic array for sums, which is the vector of sums. Yeah. And then this color can go away. So this is going to be different now. This pixels, that pixels can stay the same, but we're going to have an int, not size, but int indexes. Is width times height is 0. Or I guess it's -1. Can I do that? Does that fill with -1? I don't think it does. There's a way, isn't there? I think you can do 0 ... width times height. -1. There's like some really weird syntax that you can do in C to do this. And that will create an array of -1s. This This is horrifying. But yeah, we have range syntax in C apparently. Yeah, okay. Cool. So, what I want to do in here is basically save into indexes what the min I is, so that we can get it back pretty quickly. And then I also want to have a sums which, I mean, we have points length, so we can say sums. I think we're gonna do. We don't need a dynamic array. So sums is points dot length dot count, and it's not sums. It's a sum array. And then we're gonna say size t sums len is 0. No, sorry, not this. We're gonna say mem set sums. Int here. What does this take? Int is. I really wish that this showed me the names of the variables. Mem set. It takes the character to set it to, and then the size. Okay. So character is going to be 0. Size is going to be size of sum times points dot count. And we need to include string. Great, so this will 0 initialize this. And then we can say sums at min I dot count plus equals 1. Hue, so we need to say vector 3 HSV is color to HSV over, what is the color? So this is going to be the color of the image at our point. So it's going to be image. So this is going to be get image color. Image at our current point, which is XY. And then hue is going to be increased by HSV.x. Saturation is going to be increased by Y. And then value is going to be increased by Z. So now we're summing up the values in the image, or like the colors in the image for the given regions. And then here we need to pass in the image. So is there like a way to scale an image? Right, so we can generate an image from image. Resize. What is NN? Oh, nearest neighbor. Okay, yeah, let's do image resize. Yeah, so let's say image resize takes image, and then the new width is going to be width, and the new height is going to be height. And then here, I think you can go away. Let's leave it there. This is going to be this, and then P is now going to take an image. Or Voronoi is going to take an image. And then finally, after we've gotten the sums of all of the values, we need to actually come up with the pixels. So we can move this pixels down to the bottom. Although that breaks this. I feel like we don't really need to bother with updating the texture. So now we're going to actually generate the pixels, and to do that we're going to use the same loop. Although really we can do size t, I is 0, I is less than width times height. And then we can increase the I. And then what is going to happen here is we're going to say sums at I gives us the sum. And then we could say pixels at I is going to be color from HSV takes in the hue, which in our case is going to be s.hue divided by s.count, basically just the average. So then we're going to have s.saturation divided by s.count, and then s.value divided by s.count. And that'll set the pixel to be the correct value. And then I think that should just be it. So let's not insert a bunch of random points. And then here, let's just do like 10. Ooh, that's not what I was doing. Zoom back in a little bit. Nope, I did it again. We can zoom back in a little bit. There we go. And actually, let's just insert one random point before we get started. So like this. Oh, we got a seg fault. Hoorah. Shit. Where do we get our seg fault? Oh yeah, this is wrong. It's not going to be sums at I. It's going to be it's sums at indexes at I. Indexes, indices. I know how to pluralize words in English, thank you. Like that. Okay, so we get blue. That's promising. That's probably the average color of the entire thing, or at least that's what it should be. If we get another point up here, we get some colors. What do we get? Another point down there. Okay. If I press R, it should give us 10 random points. Maybe we make the random like additive. So instead of doing this, we just do this. Oh, that's actually cool. You can start seeing the mountain being defined. I wonder if we can find an algorithm that'll help us, or that'll like allow us to more evenly distribute these random points. But I think what I want to do is just randomly enter 50 points. Maybe start. Yeah, that's so cool. You can literally see the mountain shape. And it starts to like get more well defined as you add more points. That's actually super cool. Okay, let's modify this randomize function just a little bit so that we're gonna loop over every point that we want to add. Or okay, actually let's completely remove this. Let's do size t added is 0. Size t tries is count times 2. And then while added is less than count and tries is greater than 0, we're going to say tries minus equal, actually let's do for loop. We're going to say tries minus equals 1. And then we're going to say what? So we're going to generate a random position. this will generate a random position on the grid. And then we're going to say for size t, like this is obviously not going to be a very good algorithm. It's obviously, what is this, n squared? I guess more accurately it's n times m, n squared times m, where m is the previous number, or the already amount of points. But I think it's okay because we're not going to call this super frequently. So I is less than points count. And then let's have like a, what's a name for this? This is going to be like the minimum distance between 2 points. Min dist. And we'll say 10, I guess. I don't know if it matters. Or obviously it matters, but I don't know what a good number is. Let's do 20. If yeah, so if size t or int dist is going to be I guess this is basically the same thing that we did here. So this is going to be points, arrow, items. X here is going to be pause.x. Y is pause.y. So the distance between this point and the point in points is here, or distance squared, I guess, really, like distance squared. If distance squared is less than min dist squared itself, then we're gonna say this is like an invalid point, and we can break. Actually, we can let's go to invalid. Label at end of compound statement. What does that mean? I see. Okay, that is fine. Right, we have to do this go to garbage because we don't have like in Rust you would call this like tick outer or something, but we don't have that in C. Yeah, and then out here, if we get here, that means that this point is okay, and we can say points, or we can say DA append points in position. Wonderful. Yeah. Okay. So this should get us not quite perfect spacing, but good enough spacing, I think. And obviously, as you add more points, it's going to get a lot slower to actually deal with adding all the points. But I mean, this is pretty cool, I think. Let me add. Let's create a variable called show centers. Actually, show points is going to be false. No, it's going to be true by default. And then this is just going to be if show points. And then we're going to say else if is key pressed, key P, I guess, show points. We're going to flip that. Just so we can hide it. and then we can just add them without seeing all of them. That is super cool. I just have to say, that is super cool. Let's grab another image. We can use Unsplash again. What, nature? What kind of wallpapers do they have? What is... So I actually grabbed that one from my, what's this called, Bonjour. Yeah, because I've got... It uses Unsplash to get the background. I thought. Oh no, it uses Unsplash, but I think it's got their. I think they have their own like service for getting the random image. But yeah, okay, so that's fine then. Let's see, do we get anything good in here? This could be cool. Let's grab this. So, copy image link. What is this called? Does it have a name? It does not have a name. Star dot, I think it's a JPEG. Although it doesn't say. Okay, and then let's see what the dimensions are. So it's this. Which is that. Fantastic. I don't know how to get like the ratio. Like I don't know if there's a command line tool to be able to do that. Although I suppose it doesn't super matter. What is 16 by 9? 1.7. Honestly, I think we might be fine to just say star.jpg. It's gonna be skewed. What's the term? Stretched a little bit. But I think it's fine. Okay, so we get that. By default, it looks kind of meh, but then we start adding points. And you can see it. This one looks a little bit less great. Yeah. It's very green, which is a little bit weird because there's no green in here. But I guess that's an aspect of the hue being averaged out. What's another image? This is wallpapers. These are not horizontal like I would expect a wallpaper to be. I've never used Unsplash, so I don't really know if there's like a better way to be looking at, or like a better way to do like filtering and stuff. Let's see if there's anything cool in Berlin. Sure, let's grab this picture. Copy image link. $2760 by 1780. So that's also 3 by 2. So that shouldn't be stretched at all. Berlin. Great. And then we can say make and main on Berlin. This is a wonderful, very accurate way to see Berlin. Yeah, like, okay, so this one is a little bit of a, not great. Is there like a evenly distributed, or not even evenly distributed. I want points that are, I don't even know how to describe what I want. I want like random points with a fairly even distribution. Random points on rectangle. No, none of this is really what I want. And the problem is I don't really know how to describe what I want. Evenly spaced random points in rectangle. Maybe that's gonna be a little bit better. Yeah, something like this. Poisson disc sampling. Oh, I've heard of this. Maybe. Why is this Minecraft? Comparison of a render scene on the left with super sampled anti-aliasing and not applying what? Oh, this is super sampling. What? Why is that linked there? This seems... What? Poisson disc. The Poisson disc sampling algorithm places samples randomly, but then checks that any two are not too close. End result is even but random distribution of sampling. Okay. Do you have an example? Oh, look at that. There's just a NumPy thing for it. Fantastic. I don't care. Articles. It's really sad that so much of the internet requires JavaScript these days. Like, just for loading fucking images. Okay, this is... It doesn't seem super complicated, but it's... a bit annoying. Yeah, I don't think it's worth it. Like, I think there's a bunch of... Even some implementations are available. Give me C implementation and I'll be happy. I'm just... Oh, Irish processing can work. Processing 2D. Okay, what is this? So it's a Poisson disk 2D. Processing, for those who don't know, is a... What the fuck is this code? It's like a... I don't even know how to describe it. It's like an IDE for... like creative coding kind of thing. It's effectively like a wrapper around like Java that gives you a bunch of like utilities. I actually used to teach it to like children. It was weird. For example, in this article they use Perlin noise. Oh, I already read that. Implementations. What is this? This is another processing thing. Great. Can I just find like a Poisson disk sampling? See, I really don't want to implement this. I don't know why I'm so opposed to implementing this, but I really don't want to implement this. Repository contains a single file. I disagree. There's significantly more than just one file in here. Anyways, and to generate a set of points within the bounded region. If this is just a header-only file, then I'll grab it, because why not? Although, you know what, honestly, we could probably get pretty close by just, like, increasing this. Yeah, this is actually doing pretty well. I also want the ability to turn off the texture, in addition to turning off the points. And so we can add key T for the show texture. Just so we can get this to see what the actual point distribution looks like. Yeah, this is I think a pretty good distribution. Like it's not super uniform, but I think it's good enough. One thing we can also do if we're gonna turn off, if we're gonna have show texture, if we're gonna be able to turn off show texture, we can just do this. And this way we can do that there too, and that there too, so that we can turn off the texture and then just really quickly randomly generate one. We can bring the texture back and it'll generate it. Yeah, this isn't a terribly interesting one. Maybe we, instead of changing the string here, let's create a little bit of a CLI application. So we're gonna do int argc char ** argv, or I guess const really, and then if argc is not equal to 2, printf just standard error rather. We're going to say usage is this file, or image, is going to be argv0, and yeah, and we need a new line obviously. We're going to return 1. Then we're going to say const char * file path is argv at 1, like so. And then now we can pass in just the mountain. Cool. So that looks actually really cool. I'm actually really happy with that. How painful are you to work with? You do not look very fun to work with. Yeah, I'm not gonna. Yeah, okay, this is fine. I'm gonna stop digging into that because I don't think it really matters. I think what we have right now is good enough. I don't know, like, honestly, it looks to be about the same as the Poisson disk sampling, so I don't know if there's maybe a... sorry, I don't know if there's maybe like a difference in what we're doing versus that, but yeah, I'm pretty happy with this actually. Let's also, instead of just adding 50, let's try 1000, which is obviously going to take a minute longer, but this way it'll just start off being pretty much full. Although really not even. What if I kind of want to try doing an alternate randomize. In fact, we can just get rid of this too, I think. Yeah. I want to do like randomize, or I guess fill random, which will just literally loop until we cannot add any more pins, or until we have not added any more pins. So no more tries, no more added. This is just gonna be a while. We're gonna do this. If it's invalid, we're gonna continue. And then we're gonna say bool added is false. Or I guess we can say bool added is true while added. We'll say added is false. And we'll say added is true. And then we actually need to call that function, of course. So randomize down here gets replaced with fill random. Which definitely did not just work. Why not? So added equals false. If we don't hit anything, then added is true. We're gonna go. So why did that end? So it says we added 20. Why is it exactly 20 or 15? Oh wait, no, sorry, this is wrong. Yeah, no, this is wrong. This needs to, if this is. Do that. No, I can't. That was not gonna work. That was pretty sauce anyways. Okay, so here, if this is within the bounds, then it's invalid. Yeah, so while we've added something, or yeah, while we've added something, take a random vector. If that vector is not, okay, let's do it this way. Let's say void conflicts. Vectors points, and then vector 2D point, and that is this list, this loop. This is going to be return true. This is going to be return false. This is going to be a bool. It's vector 2D. What vector 2? Oh, it's just a vector 2. Great. This is going to be point. So if conflicts points point or pause, then we're gonna need to regenerate this point. So this while I guess do while and this is going to be paused as a vector 2 of this. We're going to use a very rare do while here. And this is going to be an infinite loop. So we need a tries. And tries is greater than 0. Like that. Maybe. Oh, this is obviously still not right. If tries is greater than 0, then we're gonna do this. Bam. So it's still not great. Tries should be 100 still. And then this will do a pretty decent job of filling it in, although not very quickly. I guess in fairness, this is now, I mean, this isn't an infinite loop, but this is, it's not quite, it's not even, I don't know, the time complexity of this is a little bit weird. I mean, it's constant time, I think. Maybe. I don't know, it's weird. Okay, maybe we don't do it like this. Maybe this is just weird. I would like to return added. This is a size t. And then basically here, instead of doing all of this, we'll just say size t added is randomize. That'll work too, I think. Or not? What? I'm so confused because that should just kind of constantly run. Printf. Added is 0. Added is always 0. Why is added always 0? That seems wrong. Oh, because we're not incrementing added. There we go. That is much, much closer to what I want. And now we can actually use this conflicts function, which needs to be declared above. And clean up this code just a little bit. So if conflicts points with position, then we're going to continue. Continue. Oh my god, continue. Otherwise, we're going to append and increment. Very nice. And I think, yeah, if I just spam R, there's probably some spots that can be filled. Like if I look here, there's kind of some stuff there. And, oh, I can also still click, right? So I can fill in as I wish. But either way, I think this is pretty cool. If we turn off the points, you just kind of, this doesn't really give you anything. This is the Berlin one, which isn't terribly interesting. But it seems to be working pretty well. Let's bring this out. And then let's also drop the distance back to 30. Or I think we had it to 25. That's fine. Yeah, look at that. That's so cool. Let's turn off the points. That is so cool. Then let's add, let's just do key space is going to be fill random points. And we'll say points dot count is 0. What is this? Oh, it's called P. And then we need to redraw the texture. Oh, we're already doing that. Bam. And then, like, obviously regenerating the points takes a fat minute. So if I press the spacebar, it does take like a second, I think. Maybe 2 seconds before it actually regenerates. But that's fine. I can do what, log ray. What's the? There's a log info or something. What's the log system? Trace log. Rebuilding, or I guess refilling random points. Just so we get a little bit of feedback when you press the spacebar. But yeah, you can see that there's definitely, it takes a minute, but it works. That's actually, that looks super cool. I do want to try it on a couple more images to see if we can get some actually cool results. And I do want to say points are off by default. Great. You can go away. Let's see, what else do we have? So we're still in Berlin. There's nothing particularly cool there. I think we'll get the best luck. Like if we look at my wallpaper here, there's just a bunch of like super bright colors. Like you've got this green, you've got this like orange and the blues, and they're fairly distinct. So if we can find something that's like high contrast like that, I think it'd be cool. I want to see what this bridge looks like. Because these are fairly, like it's a fairly high contrast image. Yeah, see, so that actually works pretty well. Yeah, that's pretty cool, actually. Let's see, what else can we get? I think like the nature things are gonna end up working a little bit better. So let's see if we go back to nature. Ooh, this could be cool. Also, for the record, I am kind of looking for a new background, and I figure might as well like generate it. Does this have a name? It does not. Let's call it poppies. Yeah, so this is a little bit of a problem. If your color spots are too small, you do just lose a lot of the detail, which is a bit unfortunate. Like, you do get some of this red, but like none of the red over here, which there's a bunch, but they're all fairly small little things. And I suspect there's some like algorithms for finding like high contrast areas in a photo. Or in an image. We could maybe consider trying to get something like that to actually generate the points and be a little bit smarter about it. That would be interesting. Let's try this. Yeah, that. Mountain 2.jpg. Okay, this one's fairly dark. I guess the image itself is pretty dark. I almost want to change the minimum distance again. Let's try something super small. Let's do 15. This is going to take significantly longer to generate all the points, obviously, because now it has more options. But yeah, then it immediately gets to be wow, this is so much slower. But then it gets to be what's the word? It has a higher resolution. I am blanking on words today. My apologies. Let's go back to the poppies, see if this looks a little bit better, because the resolution is higher. Wow, okay, those colors are all over the place. That's probably a side effect of us mixing in HSL or HSV instead of like RGB. Actually, you know what? Let's try switching to RGB. I think it'll make the blending of the colors in here a little bit better. This might be something that OKLab is better at than HSL. HSL color blending isn't super great, I think. But yeah, let's try that. So basically what we'll do is we'll say hue gets replaced with size TR, size TG, or I could do this. Size TRGB. Great. Now this doesn't matter, or I guess this part still matters. I'm gonna keep this commented. It doesn't really matter because I'm probably gonna undo it anyways. Although this would be cool to be like an actual, like a keybind to update this. But for now this is fine. So hue is going to be replaced with RGB. This is going to be called RGB. And then down here it's going to be color from... Isn't there a... Wait, how do you get a color from RGB? Oh, I guess I guess there's not a function for it. You literally just have to say color R G B. So now we're mixing in RGB, so maybe it'll be a little bit nicer. Or completely broken. This is weird. I shouldn't need to say like .r or anything. Interestingly, the bind to show... Okay, the points are there for sure. But the texture itself is broken. Which means somehow that this part is broken. Put it aside, maybe it'll just take a minute. Seems a little bit weird though. Color is R. Or color.R, where adding to R here is size T. Oh, A is FF. Yeah, there we go. So yeah, in this case, I think RGBA blending is a little bit better. So, okay. It is also just kind of cool to see where all the points end up. And then we can press space and it should shuffle all the points around again. And we should get, I mean, it'll end up being fairly similar, I think. But, yeah. Wait, did it move? I think I missed it. Yeah, it barely changes. Kind of unsurprisingly. But okay, that seems cool. So yeah, let's one more thing is I guess we can get rid of this. We're not even using that. I do want to change it so I can switch between the blending modes. So like either use RGB or HSV. So is key press key B. And then let's say blending. What is blend mode? Oh no, okay, so that's a little bit different. Color. Let's say color space. Yeah, let's do color space. Equals color, yeah, equals color space plus 1 mod n color space. Yeah, sure, that'll work. And then we can say color space. Yeah, this is going to be color space RGB by default, sure. We're going to create an enum. Except it doesn't really do that. Type def, enum, color space. We're gonna have CS RGB, 0, CS HSV is the other one. Great. And then there's an issue here because it seems to be a CS line. And then up here, so some is a little bit weird. I think we might as well just have a hue saturation value. Like, there's not really any reason not to, I think. Just like, or basically, like, the question is, do we just double these entries? And, like, obviously memory usage is higher and whatever, but I don't think we really care about that. So the option basically is, do we have just both of these entries, or do we use like a union? I think we just have both of them. I don't see any reason really not to. And no, you know what? We're gonna use a union. So union struct HSV. And this is going to be called HSV. And then we're going to have an RGB. RGB. And this is going to hold size T. Okay, that seems cool. And then, how do we use this? So, down here, we're gonna say switch we need to hold on to the, or we need to pass in the color space. And then we're going to switch on the color space. We can say color. No, actually, we can just do this, I guess. So if we get a HSV, we're going to do it this way. And if we get an RGB, we're going to do it this way. And then if we get len, we're going to say just assert unreachable. Unreachable. Like so. Great. So RGB here should be correct. We need to say .rgb. And then HSV here is going to be color from HSV. We're going to say s.hsv.hsv. And that's going to go like that. That's going to go like that. Very nice. Very, very, very nice. And then we need to do a very similar thing up here where we're going to say switch on color space. We're going to say if we get HSV, we do this. If we get RGB, we're going to do this. And then if we get the other one, that is unreachable. And this is going to be HSV. And this is going to be .rgb. Great, and then this needs to take the color space. Okay, and then finally, I want to have another thing, which is show overlay. And by default it's true, that's fine. And I just want to say, if show overlay, we're gonna draw text. We can do it at 0, 0. Nope. We can do current, I guess color space. Position is going to be 0, 0. Font size is going to be, I don't know, 12. Color is going to be color, or I guess red. Or no, let's do white. And then there's temp. What is it? S? Wait, there's a. There's a thing for printing to a string, like a temporary buffer. Text format. So this is going to be the CS names at color space. And then CS names is here. We're going to say const char star CS names is this, and there are like improved ways we can do this, like we can use macros and stuff, but I don't care. RGB HSV. Okay, maybe we do significantly larger, so like 30. Is there a way to give like an outline in draw text? I don't think so, unfortunately. That's fine. I don't care enough. Cause like we could draw a background or something too, but I don't care. Okay, so we do that, and then do we create a bind to change the color space? We did, it's B. Let's call it S for space. Okay, so we do this. If we press S to change the color space, it will regenerate. Cool. It is super slow though, that's so fun. But I think for now this is good enough. And then we can press O. Let's add just one more thing, which is O to say show overlay. And we'll just toggle that. Yeah, so we can just turn that off. And I think that's gonna be good. So let's, I'm gonna just take a screenshot of this. And yeah. So let's, let me copy that over. You can go away, make dir image, pictures, screenshots into image. And let's open the README. Deep Voronoi wallpaper. I don't want to call it a tool, an application for creating wallpapers using the Voronoi diagram. Then we can say like example. This is going to be original. Copies to image original. It's not a PNG. It's also 1 meg, which is fairly large. Let's do magic. Oh, I don't have image magic, so I don't want to. Okay, magic, original JPEG, resize. Oh, I don't. Oh, can I scale? 0.75 into original .png. 500 bytes. That seems wrong. It's 1 pixel. Oh, maybe it's percent. That's definitely wrong. Where did it go? Scale image with pixel sampling. Or no, scale the image. But it takes a geometry. Resize also takes a geometry. How do I just, like, I want to uniformly scale it down. Is that possible? If not, I don't care. I don't care. Okay, great. I do want to use PNG, though. Original JPEG. Although it's significant. You know what, fuck it. We can stick with what we have. I don't know. I have an aversion to JPEG. So original is this converted, or I guess becomes. Image screenshot. This guy. Building. Building. To build. Raylib must be installed. This guy. Let's just make running main with the image. And get init. We need to write a get ignore. So everything that's a JPEG, everything that's a PNG, main. And that is it. We do want to specifically not ignore the image, the file as an image. So now we just have what? Yeah, like that. Okay. So now get ignore, make file, readme, image, and main. Perfect. So yeah, we can say init. And then let's create our repo. Voronoi. Wallpaper. Great, public, all of that. Public readme. Oh, and let's add a license. NPX. The year is currently 2026. Right, get remote, add origin. This guy. Bam. Okay. One thing I do want to add is a link to these poppies. What's the actually, you know what? I know D told me does this in his reviews. Yeah, he's got the small text in there. What is the? I don't want to fork it. I just want to see the fucking source. Oh, it's just sub or soup. Let's just soup. Great. Perfect. So, we've got this now. That is the link right there, and that is going to be all for today. So thank you everybody for coming, and I will see you next time.